Hello, here we're going to look at 8.6, Part 1, Factoring Trinomials. Here's the why. Factoring will follow you for your entire math career. It is in your best interest to invest the time to master this skill. Today we're going to feature the easy type. Alright, and we can identify the easy type of factoring by the 1x squared out front. This is going to be important to understand. All the ones we look at today are going to end up with a 1x squared out front. Now, to start to break this lesson down, I want us to understand what factoring is. Factoring is going to be the opposite of FOIL. So let's go ahead and warm up by doing some FOIL problems, where we do x times x to get x squared. X times 5 is 5x. This gives us a 2x. And this gives us a 10. Things that will become important today. These middle two terms. I encourage you, go ahead and FOIL out these next two. Show your work so that we can see those two middle terms. Pause the video, FOIL those out, and then double check your answers. So here they are. When we FOIL these out, you can see those middle terms. I'm going to go ahead and go through and add up all the middle terms. We get a 7x, negative 3x, a negative 7x. And I can roll down the other parts as well. But I'm going to leave those middle terms there in a different color because that's going to help us out here in just a moment. Okay, so it says consider the answer you got in the numbers and the original factors. What do you notice? So what I want you to go back and look at is, and I'm going to keep them color-coded, what do you notice about positive 2 and positive 5 as it pertains to this? What do you notice about positive 2, negative 5 as it pertains to the answer? What do you notice about negative 2 and negative 5 as it pertains to the answer? Pause the video and think for a minute and think about the relationship. What do you notice? You may have noticed two things. When we have factors, and today it's always going to just start off in x and x because we're going to be working with the easy type, hopefully you noticed two different things involving the two numbers that went right here. These guys do two things at once. So the yellow terms will multiply. So I'm going to write out two things here. The two yellow terms will multiply to give us C, and they are going to add to give us B. And if you're wondering, Mr. Cottle, what are these C and B values from? We're going to use something called standard form for quadratics. It's going to be ax squared plus bx plus c. Now today is going to be the easy type, so it's always going to be a 1 out front. And you can see that on all of these, they had a 1 out front. After that, though, those two highlighted portions of the factors will do two different things. Those numbers will multiply together to give you your C value, which is the number on the end. And they're also going to add together to give you the middle term. And if we go back up and look, we will see that this relationship does in fact exist. Right? Because when I take, and I'll do a different color here, I'll circle them in red. 2 times 5 gives me 10. And 2 plus 5 gives me 7. When we're looking at the next set, 2 and negative 5 multiplied to a negative 10. 2 and negative 5 add to a negative 3. The final one, negative 2 and negative 5 multiplied to a positive 10. Negative 2 and negative 5 add to a negative 7. So what that means is you should be able to now FOIL the easy type very, very quickly. Because we know x times x is going to give us x squared. The easy type today will always start with that. But then I'm going to add the 3 and the 5 to get the middle term, multiply the 3 and the 5 to get the term on the end. Because these numbers here that I'm going to highlight in blue will add together to give you B, and we'll multiply together to give you c. All right, so we are going to do this differently in class, but we're doing it on the video, so let's move on past there, because we've already discussed some of the things that you all would have discussed if we'd been available in person. All right, so before we start to factor and go backwards, let's get some practice foiling the following in our heads. You can go ahead and write out on all of these x squared. All of these will start off with the exact same concept of x times x. Right, they're all going to have x times x to get us the x squared, because today we're focusing on the easy type. All right, and then beyond that, let's use the relationship. I'm going to go through and highlight these guys in red. All right, the two highlighted terms will do two things. They will add together to give you your middle term. And the middle term always has an x with it. So 3 minus 7 is negative 4. And they also multiply together to give you your c term. So for the next one, negative 6 plus 2 is a negative 4. Negative 6 times 2 is a negative 12. On this one, we get a negative 9x plus 8. And on this final one, we get a plus 1x minus 42. So that's the special relationship that exists amongst factors. And it's important to pause right here and make sure that you've understood everything that happened up to this point, because now we're about to start working backwards. So if you're unclear on anything that we just saw, rewatch the video, listen to it a second time, and then rejoin. We are now going to start the process of factoring. The easy type today, we'll start off with x and x. And now we're tasked with the decision of figuring out what's going to go here and here. But we know the relationship. We know these numbers need to add to b, and they need to multiply to c. So I'm thinking about numbers that add up to 7 that also multiply to 12. Now, the easiest way to do this is to look for factors of the c term. There's an infinite amount of numbers that add up to 7x. There's lots and lots. I'm just going to list some, and I'll show you why we don't typically focus on the b value. I could pick 0 and 7. I could pick 1 and 6. 2 and 5, 3 and 4, 4 and 3. All these numbers add up to 7. And that list could keep going, especially if we want to go into positives and negatives. I could say negative 1 and 8. I could say negative 2 and 9, negative 3 and 10. There's an infinite amount of numbers that add up to a positive 7. So that means I don't want to work with that list. That's not the list I'm going to start with. Instead, when we factor, we're going to focus on the factors of the term on the outside, because there's not as many of those. There's only 1 times 12, 2 times 6, and 3 times 4. There's only 3 possible ways to get a 12 through multiplication. This list is much smaller than that list. So don't start by finding numbers that add to the middle term. Start by looking for numbers that multiply to your c term. And then cross-reference, and you'll see that the 3 and the 4 is the number that adds to the 7. So I would have x plus 3 and x plus 4. For all factorings, you can check it with FOIL. X times x is x squared. X times 4 is 4x. 3 times x is 3x, and 3 times 4 is 12. When we do this, you'll see that 4x and the 3x does take us back to the 7x, which was present in the original form. So this is, in fact, the correct factorization of the initial expression. Let's try some more. So this one's going to start y and y. We're thinking about factors of 10. It's 1 and 10, 2 and 5. And which of those add up to 7? The 2 and the 5. That's how easy the simple type of factoring can be. I encourage you to pause now and try B and C on your own. Find the numbers that multiply to 20 that also add to a 21, because it starts V and V. The answer to this one is 20 and 1. 20 times 1 gives me 20. 20 plus 1 is 21. Another question that's commonly asked is, Mr. Cottle, does the order matter? What if I put V plus 1, V plus 20? These are the exact same thing. Either one of these works. It doesn't matter which order they go, as long as you have the inside components correct. So for this one, pause the video once again. Find numbers that multiply to 30 that also add to 13. The answer to that is 10 and 3. These have been the most basic type of factoring that we could possibly look at or that I could give you. We'll start to change up the signs, and that will alter some of the approaches, but the process remains the same. So this time, same concept. I have, starting off with D and D, I'm looking for numbers that multiply together to give me a 42. All right, so I have 1 and 42. I've got 2 and 21. We have 3 and 14. And we have 7 times 6. Okay, now what we have to consider though is that we need numbers that multiply to a positive 42, but they need to add together to give me a negative. I encourage you to think about what's that mean about these signs. These signs are going to have to be something special in a scenario like this. I encourage you to pause the video and think about what that might be, how we could get two signs there that multiply to a positive and add to a negative. Pause the video and think about it. Hopefully the conclusion you came to is that we're going to need double negative. And then we're going to need to pick numbers that multiply to 42, which we list them, that also add when they're both negative to a 17. And that would be 3 and 14. And let's FOIL this out to see why this works. D times D is D squared. Then I get a minus 14D, get a minus 3D. And then negative times negative brings me back to the positive. And 14 times 3 gives me the answer of 42. And these together join to create this. So that means that this is the correct factorization. So these three here are going to have the same setups. And what you'll come to recognize as you get better and better at factoring is that when you have a positive C value, you'll recognize that your signs have to match. Right? It needs to be double positive or double negative. And in this case, since I need them to add to be a negative, it's going to be double negative. This one, double negative. This one out here, double negative. So I encourage you to, continuing on from what we've learned, pause the video and find the numbers that satisfy this. So numbers that multiply to 25 that add to 10 when they're both negative. Numbers that multiply to 18 that add to 11. Numbers that multiply to 36 that add to 15 when they're both negative. Try it out, and if you're stuck, what you should do is list out factors. So 1 times 18, 2 times 9, 3 times 6. It has to be one of those combinations. Pause and try to find your answers. Here are the answers. The first one is special, and we'll have its own section to cover this. It ends up being k minus 5 and then another k minus 5, which we could shrink down to k minus 5 squared. You didn't have to know that yet. The middle one was x minus 2, x minus 9. And recall, if you had these flip-flopped, that's just fine. They can be in either order. And then the final one, negative 12 times negative 3 is positive 36, and they add to a negative 15.